Hi there! Today we are going to learn about polynomials and factor theorems. So let's look at tutorial 3. What is factor theorem? Factor theorem is whenever we have the remainder is equal to 0. Okay? So let's look at this theorem. When PA is equal to 0, then x minus a is a factor of px. This just means that the remainder is 0 when the x is equal to a. So that x minus a, when you reverse the process, is just a factor of px. Okay? Now, let's look at the example. Example 1. Determine whether the following linear expressions are factors of the given polynomials. A. I have written down the polynomial that's given, and then the question wants to check whether the linear expression are factors or not. So let's check whether x minus 3 is a factor of this polynomial in A. So x minus 3 equated to 0, the x value is 3. If x minus 3 is a factor of this px polynomial, then the value should be 0 after we have calculated this and substitute 3 inside the x. And let's see what do we get here. Simplify and calculate. You can press by using your calculator and you will see that the answer is 0. Hence, since P3 is equal to 0, then x minus 3 is a factor of px. What's important here is that the remainder is 0, which means that it doesn't have any remainder. So if it doesn't have any remainder, then x minus 3 is a factor of that polynomial. Now let's check for question B. Question B gives us the factor 2x. We have to check whether this 2x is a factor of this polynomial or not. So, what is the value of x that we should substitute? 2x is equated to 0. 0 divided with 2 is just 0. So x is 0. Substitute 0 into the polynomials. Substitute into the x's. So write down 0, substitute into the x, and then just calculate what's the value that you get. The answer is 3. Since when we substitute that value inside the polynomial, the value of the remainder is not 0, so is it a factor or not? Remember, the rule for it to be a factor is that the remainder must equal to 0, like in A. But for B, it's not equal to 0. So we should write something like, since P0 equal to 3 is not equal to 0, then 2x is not a factor of the polynomial px. Now pause the video and try to solve for C. Check whether 3x plus 2 divisor is its factor or not. Are you done? Let's check your answer. The divisor given here is 3x plus 2. So you should know what is the value of x that you have to substitute into the polynomial. Just equate it to 0, bring everything else to the right side. So it's x equal to negative 2 over 3. Substitute that x into your polynomial. And then just press your calculator and see what's the value. Now the answer is 0. So what's your conclusion? Is it a factor or not? Remember to write your conclusion. Since p of negative 2 over 3 is equal to 0, then 3x plus 2 is a factor of polynomial px. Why is it a factor of px? Because the remainder is equal to 0. Whenever the remainder is equal to 0, then it is a factor of px. Look at B. Why is it not a factor of px? Because the remainder is not equal to 0. That's why it's not a factor of px. Now let's look at example 2. If 2x plus 1 is a factor of polynomial, find the values of p. So p is situated here in the polynomial. So the only information that we know is that 2x plus 1 is a factor of the polynomial. Remember, what does it mean by a factor? Factor means that when we substitute the x value here, which is, bring everything else to the right side, when we substitute this value of x into the polynomial, the final answer that we get, since it's a factor, is remainder equal to 0. You have to remember that. If you don't remember this crucial information, then you will not be able to answer this question. Okay, next, write down your polynomial and then substitute your value of x into the polynomial and equate it to 0. Write everything down, equate it to 0. Simplify this by using your calculator. What you should get is something like this. And then just leave p on the left side as your subject and everything else on the right side, and you find your answer for p. Now you have 1 over 4 beside p, so you have to bring this 1 over 4 to the right side. Remember, when you divide with 4, when you bring it to the right side, it will be multiplied with 4. So you can cancel out the 4. So answer for p is 21. Now look at example 3. It's just an extension of example 2. Something similar, but a little bit more factors included. So you can pause this video and try it out. Have you tried it out? Let's check your answer. The first thing you have to do when you get this type of question is to take out the informations. Read the question carefully. Given that x minus 2 and x plus 1 are factors of the polynomial, find the values of a and b. So a and b is situated in the polynomial. Okay? So what you should take out is, remember, when it's given that it's the factor, means that the value of the remainder is equal to 0. Remainder of these two factors will be equal to 0. So what should we substitute into the polynomial? What value of x? Now, this is x minus 2. So x minus 2 equal to 0 is just x equal to 2. So when you substitute 2 into the polynomial, your remainder must be equal to 0. That's your first information. The next information, just take the other factor, equate it to 0, and your x value that you should substitute in is negative 1. And the remainder is also 0. Now that you have these two informations and one polynomial, you can just substitute those values inside and obtain two equations and solve them simultaneously. Let me show you how. Write down the polynomial. And then substitute our first information, which is p2 equal to 0. So this means our x is 2. Substitute in 2 inside. And then equate it to 0. Simplify this expression. You should leave a and b on the left side and the rest on the right side. Once you are stuck, this should be your first equation. Check whether you can simplify this first equation further. Can you divide everything with 2, or everything with 4, or everything with 11? But there's no common factor here, so you cannot divide it any further. Next, do the same for the next information so that we get the other equation. Substitute negative 1 into the x's. Make sure this x value here is power 3, but 2 is not power 3. So make sure your negative 1 is inside the bracket and power 3. It's the same for this x squared. So, since x is negative 1, square is for the negative 1. And here as well. And it's equal to 0. So what is negative 1 power 3? It will be negative 1 times 2 is negative 2. Negative 1 squared is positive 1. And this will be a times 1, which is a. Negative 1 times b is minus b. And then minus 5 equal to 0. Leave a and b on the left side. Everything else should be on the right side. So this is your second equation. To solve these two simultaneous equations, you can use substitutions, or you can also use elimination method. I prefer elimination method. So now I would like to subtract, or I would like to eliminate the element b, because I can see that there's a positive b here and negative b there. So I can just use the addition sign. But since in equation A, b is 2b, equation 2, b is positive 1b, negative 1b. So to eliminate the b, I have to multiply this b in equation 2 with 2 so that I can eliminate that b. Now I have to write down my first equation on top, and then below it is my second equation but multiplied with 2. So 2 times a is 2a, 2 times b is 2b, 7 times 2 is 14. And then you have to add these two equations. 4 plus 2 is 6a, 2b minus 2b is equal to 0, and then negative 11 plus 14 is 3. So you can find your value of a here. 3 divided with 6 is equal to 1 over 2. Next, to find your b, just substitute in a into the second equation just because it's simpler. So this is 1 over 2 minus b equal to 7. So bring everything else to the right side and then move the negative at b to the right side. So the answer is negative 13 over 2. Check your question. The question wants you to find the values of a and b. So now we have found the values of a and b. So that's it for question 3. Now let's look at example 4. Given that x plus 2 is a factor of this polynomial, find the value of k. Hence factorize the polynomial completely. Okay, so x plus 2 is a factor of this polynomial. So what is the x value that we should substitute? Just equate it to 0 and you find x value that we should substitute is negative 2. Substitute into this polynomial. Remember, the keyword here is the factor. Whenever it's a factor of the polynomial, the remainder should be equal to 0. Okay? So now you can just simplify this equation. You should obtain the answer for k as negative 8. Now factorize the polynomial completely. Now how to factorize the polynomial completely? So just replace the value of k at its position in the polynomial, and then remember to factorize completely means that since this is cubic, we will have 3 factors, 3 linear factors, or 1 linear factor and 1 quadratic factor. One factor that we know is x plus 2. So what is the other 2 factors, 2 linear factors? So that's what we have to find. Maybe it will be 2 linear factors or maybe 1 quadratic factor. So how to find these other 2 factors or 1 quadratic factor? We just have to divide this px with x plus 2 to find the answer. So this is just the divisor. X plus 2 will be the divisor. So how to solve this question? You have to use long division. Remember long division, you have learned this in the lectures. So write down the polynomial under the symbol inside it, and then outside should be the divisor, x plus 2. Now how to find the quotient on top of the long division? Take this value and divide it with the divisor. 2x cubed, take everything there, take all of the term, divide it with x. Okay, and then cancel this off, and your answer is 2x squared. Write that value on top of x cubed, 2x cubed. And then, remember the steps. You have to multiply 2x squared with the divisor term one by one. 2x squared times x is 2x cubed. 2x squared plus times 2 is 4x squared. And then remember to subtract these 2 values. Make sure the first value is 0. If it's not 0, then there's something wrong with your quotient term. Please check your calculation here. So 2x cubed minus 2x cubed is 0. Looks like we are correct. Next, x squared minus 4x squared is just negative 3x squared. Then just bring that one term down. Leave minus 4 behind. Next step, we want to eliminate 3x squared. So the next step is negative 3x squared. Divide with the first term of the divisor. So you cancel this off and you see that the value that we should put on top of the quotient is negative 3x. And then remember to multiply with the divisor one by one. Negative 3x times x is negative 3x squared. Negative 3x times 2 is negative 6x. And then minus these two values. So negative 3x squared minus negative 2x squared is just 0. So we are correct there. If it's not 0, then something is wrong with your quotient or at this step. And then negative at 8x minus with negative 6x is equal to negative 2x. Next, just bring the last term down. Now we would like to eliminate the first term, which is negative 2x. So negative 2x divided with the first term of the divisor, cancel it off, and your answer is negative 2. So put negative 2 on top of your quotient line. So negative 2 times with the divisor and put it down here. This is negative 2x. Negative 2 times 2 is equal to negative 4. Don't forget to subtract these two, and you see that the answer is 0. The remainder is 0 here. Remember, when the remainder is 0, what does it mean? It means that our quotient is our factor. Well, that's what we want because we want to factorize the polynomial completely. So now just write your polynomial again. Write your polynomial and then write this step. So write your divisor here, x plus 2, and then multiply with your quotient, which is 2x squared minus 3x minus 2. Now you can just press your calculator and factorize for this quadratic expression. If you cannot factorize it, if you get something like Ri on your calculator or any i's on your calculator, that means it's an imaginary number, so you cannot factorize for that expression. And if you cannot factorize for that expression, that means your final answer should be just left like this step. So it just means that you will have one linear factor and one quadratic factor. But let's check for this quadratic expression whether you can factorize it or not. Press your calculator. So you should get a factor of 2x plus 1 times with x minus 2. Write it down. So this means this polynomial is consisted of 3 linear factors, and that is your final answer. This is factorizing completely. Factorize until you cannot factorize again. Well, since this is a polynomial of degree 3, you can also press your calculator to find this line or these factors. But it's not correct. You will lose marks because you will not show this long division. In fact, you will not get any marks if you don't show your long division to find the final answer of the factorize completely step. So make sure whenever the question wants you to factorize completely, you have to use long division. And what should be your divisor? Your divisor should be at least one of the factor given. Like in this question, the factor given is x plus 2. There's only one factor given. So we just use that one factor as our divisor. But let's say if they have given us 2 factors, then you can choose either one factor, or you can also expand those 2 factors and then divide with that expanded factors. Okay. Now let's look at example 5. Try this question out. Pause the video and then check your answer after you have done it. Try example 5 out and also these 3 exercises. We will discuss the answers in the next tutorial. Thank you for watching.